Another important theorem related to polynomials and their roots is called the conjugate root theorem. The conjugate root theorem has two things to say. The first statement that we need to be familiar with is what happens if your polynomial has rational coefficients. And remember that having a rational coefficient simply means that your coefficients are ratios or fractions. That can also mean integers, because all integers are rational numbers. So the conjugate root theorem tells us that if you have a polynomial with rational coefficients, then anytime you have an irrational root to your polynomial, that irrational root is going to have the form a plus the square root of b, whereas the square root of b is that piece that's giving you the irrational root. And any time you have an irrational root in the form a plus the square root of b, you're also going to have a root that pairs up with that, and that pair will be in the form a minus the square root of b. So all we're saying here is that anytime you have rational coefficients to your polynomial and you have an irrational root, then that irrational root must have a pair that goes along with it. So that means you'll have two irrational roots, never just one. And if one irrational root is of the form a plus the square root of b, the other root has to be of the form a minus the square root of b. And as we've talked about previously when we first introduced the idea of imaginary numbers, a plus the square root of b and a minus the square root of b, those are called conjugates, which is why this is called the conjugate root theorem. The conjugate root theorem also tells us that as long as your polynomial has real coefficients, and you're never going to see a case where a polynomial has an imaginary coefficient, at least not in this class, then any complex roots of your polynomial, meaning any roots that involve an imaginary number, will also occur in conjugate pairs. Meaning that if your polynomial has a root of the form a plus bi, then there must also be a root for your polynomial that is of the form a minus bi. So really, this is all the conjugate root theorem is saying, that if you have one irrational root, you have to have another. They always show up in pairs. Equivalently, if you have one imaginary root or one complex root, there has to be a second one, because they also always occur in pairs. Complex roots and irrational roots always occur in pairs. So just keep that in mind. So let's do a quick example. Alright, so let's suppose that we're told that a polynomial has a root at 3 plus the square root of 2 and another root at negative 4 minus 5i. Given that information, we want to identify any other roots that the polynomial must also have. And so we can use this conjugate root theorem to identify the other roots of the polynomial. We just said a moment ago that anytime you have an irrational root, which is what we have right here, since we have 3 plus the square root of 2, that square root of 2 is irrational, we said that irrational roots always occur in pairs. So if we have 3 plus the square root of 2, we must also have the conjugate pair of that root, which would be 3 minus the square root of 2. So our polynomial must have 3 minus the square root of 2 as a root. In the same way, we also said that complex roots occur in conjugate pairs. So if we have negative 4 minus 5i as one of our roots, then negative 4 plus 5i must be another root. And that really is all that you need to know about the conjugate root theorem. And the whole point of this theorem is that it allows you to figure out where the roots of your polynomial must be occurring.